Hello students, today we are going to discuss BGCSE Past Paper Chemistry 2008. So the first question is uh, the table shows the pH of the solution of 4 salt dissolved in water. Which of the solution is acidic? Okay. The table shows the pH of solution of 4 salts dissolved in water. Which of the solution is acidic? First one is ammonium chloride. pH of solution क्या है in water? 5. Potassium chloride pH of its solution in water is equal to 7. Potassium nitrate its pH is 7. Sodium carbonate its pH is 9. So what is the answer? First look at this. At 25 degrees centigrade, solution with a pH less than 7 are acidic. So first see, the pH less than 7 is acidic and solution with a pH greater than 7 are basic. Solutions have pH more than 7 are basic. Solution with a pH of 7 at this temperature are neutral. So solution which have pH 7 are all neutral, like pure water. The neutral value of pH depends upon the temperature being lower than 7. If the temperature increases, the pH value can be less than 0 for very strong acid or greater than 14 for very strong bases. If we increase the temperature, then value of pH can be decreased from 0 and can also be increased from 14 for acid and bases respectively. So the answer of the solution is which of the solution is acidic. So we have discussed as ammonium chloride will be acidic because its pH is less than 7. Okay, so it is this is the right answer. Okay, let's question number 7. Which statement about the graphite and diamond is true? Which statement about both graphite and diamond is true? They have same crystal lattice structure. Their structure is same. Crystal lattice structure is same. They have the same degree of hardness. Both are hard same. They have same electrical conductivity. They can undergo the same chemical reaction. So first look this one, properties of allotrope. As we know that both graphite and diamond are allotropes of carbon. Okay, graphite is also a pure carbon, diamond is also a pure carbon, both are allotropes. So allotrope have different crystalline shape due to different arrangement of particles. Allotropes have different physical properties. Allotropes have the same chemical properties due to same chemical composition. Because they have same chemical composition, same number of electrons in outermost shell, same electronic configuration, so their chemical properties are same. But they have different crystalline shape, different arrangement of particles, and different physical properties. So let's back to the question. Which statement about both graphite and diamond is true? So they have same crystalline structure. That is wrong, as we study allotropes have different crystallities. They have same degree of hardness. That is also wrong, because we know that allotropes have different physical properties. So hardness is also a physical property. They have same electrical conductivity. Their electrical conductivity will be different, not same, because they have different arrangement. So conductivity depend upon the arrangement of atoms. Okay, and this is also not true. They can undergo the same chemical reaction. As we studied, allotropes have same chemical properties, so their chemical reaction will be same. So this is the right answer. Okay, let's go for the next. Question number 8. What is the formula of magnesium hydroxide? What is the formula of magnesium hydroxide? So see at this. Magnesium hydroxide is the inorganic compound with the chemical formula MgOH twice. Okay. Why MgOH twice? This is the right answer from all options. Why? For this we have to see the chemical properties of magnesium. Magnesium has plus 2 charge, so to make it stable we have to add 2 OH minus, so positive and minus negative charges become equal and it become a stable compound. So all other compounds are not true. Okay, option B is the right answer, MgOH twice. Okay, next question. Which atom has the greatest number of electrons that can be bound with other atom? So this is very important question from the periodic table. Which atom has greatest number of electron? Okay, so as we know, the outermost shell electrons take part in chemical reaction. Okay, only the valence shell electrons take part in a chemical reaction. So the element have more valence electrons will have more bonds. Okay, so let's look on one by one on their electronic configuration. In aluminium, okay, first element is aluminium, second is phosphorus, option C is sulfur, and option D is silicon. So first look in the aluminium electronic configuration will be, okay, 1s2 2s2 2p6 3s2 3p1. Let's see, outermost shell is 3s2 3p1. Okay, only 3 electrons in valence shell or outermost shell. The configuration notation provide an easy way for scientists to write and communicate how electrons are arranged around the nucleus of an atom. This makes it easier to understand and predict how atom will interact to form chemical bond. Aluminium has 3 unpaired electrons in outermost shell, so it can form 3 bonds. So aluminium can form 3 bonds. Okay. Next, the phosphorus electronic configuration will be 1s2 2s2 2p6 3s2 3p3. So look at the outermost shell only. It has 5 electron. It has 5 electron in the outermost shell, so it can form 5 bonds. So phosphorus can form 5 bonds. Aluminium can form 3 bonds, and no phosphorus can form 5 bonds. The sulfur electronic configuration will be 1s2 2s2 2p6 3s2 3p4. Okay, it has a empty 3d orbital also. So the 3s2 and 3p4, this is the outermost shell. It has 6 electron in its outermost shell, so it can form 6 bond. So sulfur can form 6 bond. This is the most, I think. The silicon electronic configuration will be 1s2 2s2 2p6 3s2 3p2. So its outermost shell has only 4 electron. So it has 4 electron in its outermost shell, so it can form 4 bond. So silicon can form 4 bond. So the which one can form most bond? Only the sulfur, because it can form 6 bond. So this is the right answer. Okay, let's see the last one. Which compound has the functional group C double bond O O, okay, in its molecule? So this is like functional group. So which molecule will have this one? So first is carboxylic acid, second is aldehyde, option C is ester, and D1 is ether. So first look at a carboxyl group is a functional group consisting of carbonyl group C double bond O with the hydroxyl group OH attached to the same carbon atom. So this is the carboxyl group, okay, COOH, in which one group is C double bond O, and on the same side OH is also attached to the same carbon. So This is the carboxyl group. Okay, this is functional group is carboxylic group. Now look at the other. Chemically, an aldehyde is a compound containing a functional group with the structure CHO consisting of a carbonyl center with the carbon atom also bonded to hydrogen and to any generic alkyl or side chain R group. Okay, this carbon also bonded to any R group. Okay, R may be any group, and it is double bonded by with oxygen and also form a single bond with hydrogen. The functional group itself is known as aldehyde or formyl group. Ester are a functional group commonly encountered in organic chemistry. They are characterized by a carbonyl bond to three other atoms. Okay, carbonyl bond to three other atoms. A single bond to carbon, a double bond to an oxygen, and a single bond to an oxygen. Okay, so this is a ester group in which one single carbon atom form uh, also four bonds, two with oxygen, ठीक है, a double bond with oxygen, a single bond with oxygen, and single bond to a carbon. So in this way, this is the ester group. Last one is ether. The ether functional group consists of an oxygen atom that forms single bond with two carbon atom. In this way, this one is R. This is R carbon. This R is also carbon, and between them is a oxygen atom. So these are the four groups, the functional groups: ether, ester, aldehyde, and carboxylic acid we studied. So in the question, this group is a carboxylic acid. Okay, so carboxylic acid is the right answer.